Have you ever wondered what actually happens inside Linux when you type a command like ls or pwd? You press enter, and within a fraction of a second, the command runs and displays the result. But what happens behind the scenes? In this video, we will write our first bash shell script and understand how Linux executes commands automatically. By the end of this lesson, you will be able to write, run, and understand simple bash scripts, the foundation of Linux automation. Welcome back to the Linux Fundamental series. In the previous lesson, we have learned how to automate tasks using cron jobs, but cron does not magically know what to do. It usually runs a shell script. So today we will learn how to create our own bash scripts. If you are planning a career in Linux, system administration, DevOps, or cloud engineering, shell scripting is one of the most valuable skills you can learn. Bash stands for Born Again Shell. It is the default command line shell on many Linux distributions. Whenever we type a command in the terminal, Bash interprets it and communicates with the Linux kernel to perform the requested task. So, is Bash the operating system? No. Bash is simply the interface that allows us to interact with the operating system. A shell script is simply a text file containing multiple Linux commands. Instead of typing those commands one by one every time, we save them in a file and let Bash execute them automatically. For example, imagine you check disk space, memory usage, current date, and running services every morning. Instead of typing 4 or 5 commands daily, you can write them once in a shell script. Why use shell scripts? For automation, perform repetitive tasks automatically. Save time, write once, run many times. Reduce errors, no need to remember long command sequences. Consistency, the script performs the same steps every day. This is why shell scripting is heavily used in Linux administration and DevOps. A shell script is just a plain text file. You can create it using any text editor such as Nano, Vim, or VS Code. The .sh extension is a common naming convention. Linux does not require it, but it helps us identify shell scripts. This is typical structure of a bash script. Shebang. The first line tells Linux which interpreter should execute the script. The echo command simply prints text to the terminal. Every bash script begins with a shebang line. When we create a file, it does not automatically have execute permission. The chmod plus x command grants execute permission so Linux knows this file can be run as a program. Remember our video on Linux file permissions? This is a practical use of the execute permission. The // tells Linux to execute the script from the current directory. If you simply type hello.sh, Linux looks for it in the system path, where it usually won't be found. Variables allows us to store information and reuse it throughout the script. For example, instead of writing the same value multiple times, we store it in a variable and refer to it whenever needed. Variables make script flexible and easier to maintain. Comments are ignored by Bash. They are written for humans, not computers. Comments are useful because they describe the script, explain complex logic, help teammates understand your code, help you understand your own script months later. These are few best practices. Use meaningful file names. Add comments. Test your scripts. Keep scripts simple. Use variables whenever appropriate. Let's keep all our practice scripts in one folder. Let's create our first script. The first line is shebang line. It tells Linux what interpreter to use. The second line is a echo command that will display the text Hello Linux. Let us save the file and check the permissions. Notice that the execute permission is not yet set. Let us give the file an execute permission using chmod command and verify again. Now we can see that everyone has execute permission on the script. Let's run the script. Congratulations! You have just created and executed your first bash script. Let's build a practical script. Add a shebang line, then a few commands. This will print the host name on the screen. Let's save the file, close the editor, and verify if the file has execute permissions. We can see that the file is created but it does not have an execute permission. Let us make it executable and re-verify. Now everyone has an execute permission on the file. Let's execute it and we can see that the script has printed host name on the screen. Let's add one more command to the file. Save the file, close the editor, and execute the script again. The script has printed host name and the current user on the screen. Let's add more command to the file. Save the file, close the editor, and re-execute the script. Along with the hostname and current user, now the current directory is also printed. Let's add one more command to the file. Save the file, close the editor, and re-execute the script. Now, in addition to the previous commands, current date is also printed. Let's add a variable to the script. To call a variable, we have to use the $sign. Let's save the file, close the editor, and re-execute the script. Now we can see the variable has printed administrator is equal to the name, that is Dinesh, on the screen. So we have seen that in a bash script, We can execute multiple commands in sequence. In our example, the host name, the current user, current directory, current date, and a variable we have used. These are some common beginner mistakes. Forgetting the shebang, not giving execute permission to the script, using a wrong file path, forgetting dot slash while executing the script, saving the file without executable permission. Today you have learned what bash is, what shell scripts are, how to create and execute scripts, how variable works, and why shell scripting is the foundation of Linux automation. We have now learned how to work with Linux from basic commands and file management to networking, automation with cron, and writing shell scripts. In our next and final lesson of the Linux Fundamentals playlist, we will bring all these concepts together by exploring Linux architecture. You will finally understand what happens inside Linux from the moment you type a command and until the result appears on your screen. Congratulations on completing another step in your Linux learning journey. If you found this video helpful, please consider liking the video and subscribing to the channel. Your support helps me to continue creating beginner-friendly Linux and DevOps tutorials. I will see you in the final lesson of this Linux Fundamental series, Linux Architecture Explained.